Hello there. This is a short video that will introduce you to the basics of the unit circle. Understanding the basics in this video will help make many problems in physics easier to solve and easier to understand. Let's start with the name, the unit circle. Why is it called that? The word unity in math means 1. The unit circle has a radius that is equal to 1. Let's start by thinking about the Cartesian coordinates. Let's write the xy pairs that lie along each axis as I've shown in the figure. So my first one that lies on the positive x-axis, that's going to be 1, 0. It has no y value, so that's why it has 0. My next location that I'm interested in thinking about in terms of an xy pair is the one that lies directly on the y-axis. And so that's going to be a 0 for x and a positive 1 for y. Next, we will identify the location of the point that lies on the negative x-axis, and its xy pair should be negative 1 for x and 0 for y. Finally, we will look at the location that lies on the negative y-axis, and it should have a 0 for the x and a negative 1 for the y. All right, so let's recall how we go around a unit circle. We start right there along the positive x-axis, and then we go around the circle in a counterclockwise fashion. All right, now let's break down what the radians are as we go around the circle. We start out at 0, and then halfway around the circle, we are located at pi radians. And once we have completed the round trip, we are at 2 pi radians. Now we will divvy up the locations in between. Halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 1.5 pi, which we usually write as 3/2 pi. All right, now let's throw degrees on our circle because some people are more familiar with those. We start out at 0 degrees, and one entire trip around the circle is 360 degrees. So halfway around the circle is 180 degrees. Halfway between 0 degrees and 180 degrees is 90 degrees. And finally, halfway between 180 degrees and 360 degrees will be 270 degrees. All right, let's think about this radius now. Recall it's 1, and we're going to look at it not running directly along an axis now. And we're going to think about our right triangle geometry that we've used before. So x is adjacent to theta, so it will use cosine, and y is opposite theta, so we will use sine, and again, my r is 1. So a nice conceptual moment that I would like to point out here is that I have drawn my theta in the figure as less than 45 degrees. And when that happens, cosine of theta will be greater than sine of theta. When I change things up and draw my radius such that theta is greater than 45 degrees, I can see that now cosine of theta is less than sine of theta. Let's go around the circle again, this time using radians, and we're only going to look at the locations where the radius lies directly along an axis. When theta is 0, cosine of 0 is 1. It's the same as the radius. And the sine of 0 is 0 because there is no component that lies along the y-axis. Now let's look at when the radius lies along the positive y-axis. In terms of radians around our unit circle, that's pi over 2. Sine of pi over 2 equals 1, and cosine of pi over 2 equals 0. As you can see in the vector, there is no magnitude to the cosine component or the x-axis component. It all lies along the y-axis. Now let's sketch when the radius lies along the negative x-axis. In terms of radians, recall that that was my pi location. Now I am all x component, which is cosine, and no y component, which is sine. Cosine of pi is -1. It's negative because it lies along the negative x-axis, and the sine of pi is 0. Let's draw in our last one. It lies directly along the negative y-axis. So I'm sketching in both my x and y components there, and you can see that the y component lies directly along the same vector as my radius, and the x component is 0. So the cosine of 3 pi halves is 0, and the sine of 3 pi halves is -1. It's negative because it lies along the negative y-axis. So a quick summary. When our radius is at 0 radians, the cosine is 1 and sine is 0. When the radius is at the pi over 2 location, sine of pi over 2 is 1 and cosine of pi over 2 is 0. When my radius is at pi, the cosine of pi is -1 and the sine of pi is 0. When my radius lies on the location of 3 pi over 2 radians, the cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is -1. As we go around the unit circle, cosine starts at 1, then it goes to 0, and then to -1, and back to 0 again. As we go around the unit circle, sine starts at 0, then goes to 1, back to 0, and to -1.